Hey everyone, thanks so much for coming to the RL Hackathon. Woo! This is a big, big moment for us, and I think for open source everywhere. You know, we're getting to see all these RL models come out. How do we make them? How do we get the opportunity to do this ourselves? So, you know, in support of open science, we want all of you to get to use our repo. We'll be giving you guys a breakdown on how it works, and hopefully we can put together enough environments to you know, maybe make AGI. No, I'm just kidding. So anyway, without further ado, we've got 3 talks for you, beginning with one very important talk from Roger Jin, who's going to be talking about how Atropos works, documentation, and judging, and how we're going to go about the hackathon. So thank you for being here, and without further ado, Roger, you got this. Woo!
Hey guys, I'm Roger, and we're going to kick things off with an introduction to the repo. So for the past decade in ML, we can kind of characterize it as this age of scaling up data. So we want large data sets, very diverse data sets, high quality data sets. But now our base models are actually strong enough that we can teach them with a different kind of method. So not just telling them what is correct, but allowing them to explore an environment and figure it out for themselves what is good and what is bad. So if we could forecast what's important to do for the next 10 years, it might be scaling up environments. And so currently, if we read the literature, it seems like people are mainly interested in these 2 kinds of environments, like math and code. So how are we doing right now, in terms of scaling? We have these trillions of tokens of SFT data, let's say, but we have kind of 2 environments. That's the state of things right now. And we plug in our LMs to these math and code environments and let them train, and we kind of pray for generalization to all the other domains. So the purpose of this hackathon, or at least one purpose, is that we don't want to just hope for generalization. We just want literally an RL environment in every single domain. So we can literally train an LLM to figure out for law, for medicine, et cetera, what is good and what is bad. So we're faced with this question of how do we train an LLM on these thousands or millions of domains? What are the abstractions that will allow us to scale this up? What will the next million environments all have in common, basically? So let's think about this question for a bit. What even is an environment, or how do we define one? So one way we could possibly define an environment is that we can think of these environments you can have a math problem, and then the element attempts to answer it, and we parse the answer, and we try to ground truth. We try to match it against the ground truth. Does it get it right or wrong? So that situation works for a lot of these environments. But what about a multi-turn environment? So the LM is playing multiple rounds of poker or something, let's say, and making bets and getting rewards at each stage. If it gets these scores in the middle, you have to go back and forth between the rollouts and the scoring. How do we deal with that with just a rollout and scoring abstraction? So that becomes a little bit challenging. So maybe we can consider using Gymnasium. So in Gymnasium, we can have actions or entire messages, assistant messages. And so now it's easier to play these multi-turn games. But then what about multi-agent? So there's natural extensions of Gymnasium, like petting zoo, which basically allow for, it's like Gymnasium, but with turn-taking between agents. But now if we think about turn-taking between agents, what if they're playing Super Smash Bros, right? And in Super Smash Bros, the real-time actions of the agents and how fast they think and actually matters. So allowing each agent to think for some variable amount of time and then having them take the action isn't a realistic simulation of Super Smash Bros, where the thinking time, the actual thinking time matters, right? So maybe we can support fancier things like petting zoo parallel, but then there are other considerations, what about token level rewards? What about multiple environments at the same time? So it becomes quite complicated, I guess. So Atropos is our answer to this question of how do we scale up RL training on LLMs to the next million environments? Yeah. So let's take a step back and consider what does RL infra for LMs look like, I guess. So we have these three parts traditionally: a trainer, which is responsible for backprop. The trainer will send policy updates to this inference engine, VLM or SGLang. And then there's going to be these environments which are going to talk to the inference engine to produce rollouts, and they're going to send data to the trainer. So our perspective on this is that like the environments should just like be able to do whatever they want as long as they're able to produce data for the trainer. So we think about environments as sort of data loaders for this trainer, and this trainer can just be some kind of like minimal thing that's doing something like weighted SFT on this data that's being sent by the environments. So these environments can be multi-turn, multi-agent, sort of like whatever you want. Okay. So more concretely, what does an Atropos environment look like as a developer? So we're mainly thinking about these two methods: a getNextItem method, which is responsible for producing a data point, maybe like a row of a data set, like a problem to train on, let's say. And then this collectTrajectories method, which is responsible for producing a group to pass to the trainer to train on. Okay, so getNextItem, this is an example of one from, it samples a row from GSM-8K, and then it returns it. If you can get fancier with getNextItem, for example, if you want to do some kind of curriculum learning, getNextItem is a great place to manage the curriculum. Okay. And then the more interesting method is sort of collectTrajectories. And we've taken a couple of design choices here, which are a little bit idiosyncratic, a little bit different from other alternatives. So one of these is that the inference and scoring, the inference and rewarding, are actually fused inside collectTrajectories. So you can still have separate abstractions for inference and scoring. We would just expect you to call both of these within collectTrajectories. And so in this case, like this just kind of takes care of these like multi-turn with like process rewards and so forth, where we don't actually care like how you guys produce the scores or how you guys produce the rollouts. You just like do whatever you want and then give us the data. Another design choice we've taken is that the atomic unit of data, the data atom, is not actually a single rollout, but a group of rollouts. And this is because in RL for LLMs, we have this like tendency to like to do contrastive learning. So for example, data for DPO, GRPO, and like reasoning traces from MCTS all have this kind of shape of like you want to pack together things that are like similar but like slightly different. And then lastly, we have this characteristic of the environment that our environments actually return tokens to the trainer and not chat messages. So this is very strange, but enables things like, for example, if you're doing multi-agent and you want to have a custom chat template, like you don't want user assistant role, you want like player 1, player 2, player 3, ... Then you can build this custom chat template, and that doesn't interfere with like other environments. The trainer doesn't even have to know about your chat template. That's all taken care of on the environment side. If you wanted to do something like credit assignment to like at the token level, we have this advantages override, which you can use to actually assign a weight to each token. And this will override the GRPO advantages for the trainer. If you want to use messages, though, we still support that. For example, for multimodal, that's a useful feature. Okay. So each Atropos environment also comes with a CLI. With these two subcommands, serve will run the environment and kind of send the data to the Atropos API. It'll spin up the environment as a microservice for training. And then process will run the environment and kind of like save and collect data and visualize it. So for today, for the hackathon, you only need to really worry about process. This is an example command, and the slides will become available to you after this talk, so you don't have to like memorize this or anything. But you can configure like your OpenAI like base URL, API key, model name, and that kind of thing. Okay. So the output of the process command will be like three things. It's going to be a JSON-L file containing the output of this, the rollouts, the scores, and so forth. An HTML file which visualizes the JSON-L, and then also one weights and biases link which will contain some of the like a rollout table and the scores, and some metrics that you might choose to define. Okay. So now I'm going to introduce Artem, who will go over some example environments.
How's it going? So I'd just like to show two environments that we made, and we think that each one has an interesting idea that it's just worth thinking about, or you might see in an upcoming news model. And first environment is KernelBench. So writing CUDA kernels is really hard, and we want LLMs to do it instead of us. we need LLMs, to transpile PyTorch operators from maybe some code that researchers wrote in PyTorch into correct CUDA code that compiles and is also faster than the reference PyTorch code. And so KernelBench is like an awesome resource for getting started with this, and it's 250 tasks across 4 difficulty levels. The first level is very simple stuff like matrix multiply, matrix vector multiplies, and levels 2 and 3 are like kernel fusions, and level 4 is you optimize like a Hugging Face model basically from scratch. So you give the LLM the whole thing and just tell it to turn the whole thing into CUDA. So we want the reward to be correctness and performance. So, when we start off training with RL, GRPO, most of the outputs of the rollouts aren't even going to be correct. They're not even going to compile, especially if it's a smaller model. And we took the reward function actually from a cognition blog post where they trained a model called Kevin. So we have a coefficient of 0.3 that handles, did the CUDA kernel compile and is it correct? And we add to that the ratio, when we profile this kernel, how much faster it is than the reference PyTorch code. But then we realized that, this is actually an interesting sort of problem because the output is, if it's a great CUDA kernel, that's extremely valuable because it means that you could, speed up your inference for your model, directly saving money and time. So we would like the performance to be as good as possible, sometimes on a single kernel. So the question we had is, if it's that valuable, can you train on a single kernel and then discard the model later? So meaning, would you be able to purposely overfit using this reward function on a single kernel and potentially get something, better than what you would get, if you train on like all of the kernels and then try to generalize to new ones. And the second environment is visual tool calling. And kind of the second interesting idea is, what does tool calling look like for a vision language model where you're giving it images as input? And OpenAI demonstrated one version of this with the zoom tool. So if you give an image to O4 Mini, it could start a reasoning process where it zooms into different parts of the image and uses that in its chain of thought. Another idea that we had is, if you take a model like Qwen 2.5 VL, the LLM portion is 7 billion parameters, the vision encoder is much smaller. And can you let the vision language model delegate some of the fine-grained perception, like pixel-level accuracy things that a model with a small vision encoder like this might not be great at, and then let it reason over the tool outputs. So what tools? We came up with YOLO object detection and SAM2 segmentation. And here's an example of what it will look like. So the model during inference could call an object detector tool, and it actually gets the labels and the exact bounding boxes. So this could improve the pixel level accuracy of the model massively while not actually changing, or majorly retraining the vision encoder of the model. I'll hand it back over to Roger. Thanks.
Okay, so now that you've seen some examples, I'm sure that you're itching to implement some Atropos M's of your own. So we're going to go over the hackathon rules and criteria, and then I'll hand it over to the other speakers, and then it'll be time for you guys to start. Okay, so today we have 2 tracks. We have an objective track where this is for environments where there's like sort of a natural or agreed upon notion of correctness or goodness. So for example, like we already know the ground truth answer to a problem, and it could be that we use some like kind of Python program to compute the exact match, or we use the LLM as a judge to measure similarity. Maybe we have some kind of environment where like if the compiler accepts it, then accepts the program, then we reward, and if it doesn't, then we punish. we also have the subjective track, where maybe the notion of correctness or goodness is more vague, or maybe opinionated, or different people can disagree on it. So for example, literary translation, like do we care about more about like preserving the essence, or do we care more about like preserving the literal meaning? Or even for more technical things like putting the human element back into a technical domain. So for example, maybe some people have a certain taste in like math. They think like maybe like, oh, complex analysis is like the most beautiful like area of mathematics or something, and like these are like some examples of like beautiful proofs like in complex analysis. So if you wanted to teach an LLM that like to appreciate the beauty of like mathematics or like generate a beautiful math solution, like this is something that's more subjective. Okay. So we will allow each team to submit one environment to each track as 2 separate PRs. You're not required to submit one to each track, so you can just pick one, but you're allowed to submit one to each track. Some environments we know might blur the lines between these two, so if you're uncertain, you can ask us, or you can also add a justification for why you chose this track to your submission. Okay. Okay, so we've got some cool prizes for you guys, and this is per track. So it's going to be first, second, and third for objective, and first, second, and third for subjective. So for each first place, we got $10,000 in cash, $3,000 in NVIDIA credits, $1,500 in RunPod credits, and tickets to the AI Engineer World's Fair. In second place, we got $5,000 cash, 1.5K NVIDIA credits, and $750 RunPod credits. And in third place, $2,500 cash, $500 NVIDIA credits, and $250 RunPod credits. Okay, so this information again will be, you'll have the slides, and you'll also have this like hacker resources doc that will outline this. No need to like kind of take pictures or whatever, but you're all going to be submitting per environment that you submit a pull request to Atropos under this folder environment/hack0, containing like a Python file that's like your environment implementation. The requirements.txt, or if your environment is more complicated, just like include the more complicated setup instructions in your README. And your README will be a little bit different from traditional READMEs. It'll also contain a link to a 1-minute demo video, like just like going over your environment. And it could be that your environment takes a while to run, so you're allowed to like speed it up or edit, clip this video as you wish. Okay. It should also contain explanation of your environment design and motivation, some quick start docs so that the judges, if they are very interested, they can like try to reproduce your environment or run your environment. And one of the outputs of the process command is public WAN-DB run, so this should be also linked. There's a method I didn't really talk about called evaluate inside inside these environments, and inside evaluate, like these are validation metrics that you can use to kind of measure how well your environment is doing during training. So for example, if you're training on like chess games, maybe as a validation you can like measure how well the model is doing against like chess puzzles. So we will look for clever ways that you can use to measure how well your model is doing during training. And you should think about like how expensive these metrics are to kind of compute. So like for example, chess puzzles is like much easier to, solving like a mate in 5 puzzle is much like less expensive than like playing out an entire game to kind of track the progress. Okay. And then any additional details about your environment, like if you thought about reward hacking or something, like you can include it in this additional detail section. But keep in mind that judges are only required to read 500 words of this submission. So you're welcome to write a lot of detail, and judges are also like allowed to read everything, but they're only required to read 500 words. Okay. And then as a .zip file attachment to this PR, we want the other outputs from process, so a .jsonl, and then you can optionally also include the .html produced by process. The .html that visualizes the conversations in the .jsonl doesn't have full feature support, meaning like it only supports single turn with like outcome rewards. So it could be that like the .html is not like very informative about your environment, in which case you can kind of exclude it from your submission. So we have a panel of like very experienced and knowledgeable judges from many companies that you may have heard of. So I'll just like flash this slide for a little bit. And they're going to be here for judging, but then also some of them are already here and going to be walking around to help mentor people. So you may run into these people. So the criteria for judging, it's going to be 25% impact. So like how much utility you bring to your like target audience. And for subjective, we know like it's a little bit hard to justify it. But for example, if you're writing creative stories and this like makes people happy, this is what we want to hear about. The demo and submission, your video and the PR, that's going to be worth 50%. Yeah. Okay. Yeah, so creativity is going to be worth 15%, and like how original your environment is, like have the judges like thought about this before, like have we seen this in a paper before? And then you're all going to have the opportunity to pitch to a panel of judges, so that's going to be worth 10%. Okay. We have a lot of resources for you guys. So one of us, Dakota, has prepared an example submission as a PR at the Atropos repo, so please take a look at that. We also have the Hackathon Discord. If you scan the QR code here, it'll take you there. And then for tech support, if you find bugs in our repo, just file an issue on GitHub. For other questions, we have a hashtag news channel on the Discord, and you can pop your questions there. We also have this hacker resources doc containing, you guys may have already received this. And of course, our mentors will be walking around to help people with individual questions. Okay. Here's a schedule for the rest of the day. So we're going to have some talks until around 11:45. We'll have lunch at 12, 5:45, 6 hours after hacking starts, the projects will be due. At 7, we'll have some evening talks and remarks. 7:15, the final judging panel for the top 6 will happen. 7:45, we'll announce the winners. And then 8 p.m. to 11 p.m., we'll have an after party. Okay, thank you.
All right, everyone, so with that, we are officially open and the hackathon has begun. I just wanted to let everyone know, I know a lot of the merch got picked pretty clean. We are going to be, you've seen some of these going around. We have some new merch that we're putting out later today. So don't worry if you didn't get anything now, we're going to be putting out some cool new stuff later. So there will be lots more merch to have. All right, let's get building.